Visual representations are an important part of problem solving in today's math classrooms. There's a significant level of support for visual representations in the IES problem solving guide that you'll be looking at through these different sessions. You're going to find 3 how-to steps associated with this recommendation, and in that you will learn how to select visual representations, how to use think-alouds to teach visual representations, and most importantly, how to connect visual representations to mathematical notation or number statements. In the past, math educators have led teachers to believe that all you really need to do is present students with visual representations or manipulatives, and those things will do the job in and of themselves. There's not a lot of support for that kind of practice, particularly with struggling learners. How-to step 1 presents an interesting balance between how teachers select representations and how students use them in the classroom. Specifically, teachers only need to use 2 or 3 representations for a particular topic or type of word problems. For example, with ratios and proportions, you'll see that number lines, double number lines, tape diagrams, tables are sufficient for teaching ratios and proportions. You don't need, say, even more than 2 of those. At the same time, it's important to remember that in introducing just a couple of representations, some students may prefer one over the other. So for example, in basic subtraction and addition, students may be shown tape diagrams, but in the end they may rely on tick marks or counters to do their problem solving. It's important also in step 1 to think about the size of the numbers in word problems. After all, you want kids to concentrate on the visual representation and not on the tedious calculations or complex calculations that may lead to mistakes. How-to step 2 is an important step insofar as teachers use think-alouds to talk about problems. They model for students or solicit from students ways of thinking about problems before they solve the problem or as they're solving the problems. Sometimes we take this for granted, but it's important for teachers to be able to talk out loud about what's important in the problem, what information is irrelevant, most importantly, how this particular problem may be similar or different from problems they've solved in the past. This is an extremely important thing for teachers to do, particularly as they teach a visual representation and lead kids from an initial state where they may not use representations or use more primitive representations and generate more sophisticated ones. I can think, for example, of working with elementary students where you're trying to get them to use a visual representation associated with the word problem. The instinct on the part of many students is to draw elaborate pictures or images that contain a lot of irrelevant information. It takes structured work and feedback to get students to move from an elaborate drawing to a simpler line drawing, or what's called a schematic diagram, so that they're more successful and efficient in their problem solving. How-to step 3 attends to something that's found in recommendation 5 of the IES problem solving guide, and that is this connecting of the visual representations to mathematical notation as well as getting kids to articulate their thinking. So one of the key things that happens as we're connecting visual representations to math notation is to be sensitive to the fact that as the numbers and problems get larger, sometimes the visual representations change. For example, if I have $55 and you have $39, how many more dollars do I have than you have? There's a tendency on the part of some students to draw 55 tick marks and scratch off 39 of them to find the difference of 16. This is inefficient, and students need to move to representations that deal with decade quantities, the tens. So for example, they may use long lines or dots to represent tens and ones as opposed to a series of individual 1 tick marks. I cannot stress enough how important it is to pair the visual representation with, say, something like a number statement or notation. In today's word problems, and again to go back to simple elementary word problems, the unknown quantity may vary in its location. Traditionally, the unknown quantity has always been at the end. If I have $10 and I'm given $5 more, how many dollars do I have? But today's word problems also include the unknown quantity at the beginning or the middle. I have some dollars, I'm given $5 more, and I end up with $15. How many dollars did I have in the beginning? Enabling students to be able to see how the representation connects to these kinds of number statements is critical so that kids can understand what the math at the end ultimately looks like. There are a couple of roadblocks to consider when we think about the use of visual representations in math problem solving. The first, and it's pretty obvious, is for a lot of teachers, they don't have those visual representations in their curriculum. The good news is you can find these visual representations in any number of professional development materials and even online. Again, as I said, with ratios and proportions, all you need are things like double number lines or tape diagrams to do the job. And it's a matter of sticking with it and being persistent as you use them. But a related roadblock comes up when students tend not to find these particular representations useful. I can think in particular working with highly capable elementary students where the feeling was, why do I need to do all this showing my work? I can just give you the answer. That strategy may work for fairly simple problems, but as problems become more complex, there's a tendency to make mistakes, to have all kinds of errors by skipping over an intermediate step, visually representing the quantitative relationships in a problem and ultimately moving to the notation. For that reason, I think you'll find that visual representations are an incredibly important bridge between the word problem and the notation and answer to a problem.